All right, the next lesson in geometry is called secants, tangents, and angle measures. Okay. Now we did tangents yesterday, so we call that a line that intersects a circle at exactly one point is called a tangent. Okay, a tangent line. Okay, and this is new. A line that intersects a circle in exactly 2 points is called a secant. Okay, secant. Okay, so I mean, pretty obvious. Look at QR. QR intersects the circle at 2 points, so QR is a secant. Okay, line QR is a secant. Okay. So let's see. There's a few theorems today. Here's the first one. If two secants intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, that's a little wordy. So let's go through it a little slower. Okay, so we have two secants intersecting in this circle. Let's focus on angle 1. Okay, angle 1 equals 1/2 the measure of arc AC plus the measure of arc BD. Okay. So the measure of angle 1 equals 1/2 the sum of the measures of its intercepted arc, which is AC, and the arc from its vertical angle, which is BD. And similarly, the measure of angle 2 equals 1/2 the measure of arc AD plus the measure of arc BC. Okay. So let's go ahead, let's try example 1. Find the measure of angle 1 and the measure of angle 2. Now, you may be tempted to say that the measure of angle 1 equals 30 degrees, but that's not correct because angle 1 is not a central angle, okay? If angle 1 was a central angle, then you could say that it equals this intercepted arc, which is 30, but it's not a central angle, okay? You can see it's not in the center of the circle. Okay? So here's what we're going to do. I'm going to say that the measure of angle 1 equals 1/2 the measure of its intercepted arc, which is 30, plus the measure of the arc from its vertical angle, which is 20. Okay? So in other words, 1/2 times 30 plus 20. Okay? So the measure of angle 1 equals 1/2 times 50, which is going to be 25 degrees. Now there's 2 ways to get the measure of angle 2. Let's start by doing the fast way, what I think is the fast way. 1 and 2, that's still a linear pair, so they still add to 180. So I can say that the measure of angle 1 plus the measure of angle 2 equals 180. We just established that the measure of angle 1 is 25. So 25 plus the measure of angle 2 equals 180. 180 minus 25 equals 155. There's another way you could do this, okay? So I'm just going to do that on a separate piece of paper, just because I'm running out of room, just to show you real quick. The other way you could do it is like this. Okay? The measure of angle 2 equals 1/2. If these two angles add up to 50, if these two arcs add up to 50, then the other two arcs have to add up to 310 because all the arcs in the circle add up to 360. So if these two add up to 50, then the remaining two add up to 310. So using the theorem right above, 1/2, measure of angle 2 equals 1/2 of 310, which equals 155. So that's the other way you could do that. You know what? I'm just going to write that right here because I'm going to post this online. Alternate method. So the measure of angle 2 equals 1/2 of 310, which is 155. You can see you get the same answer each way. However you want to solve for that is fine. Either way is fine. Okay. Here we go, this next blurb. A secant can also intersect a tangent at the point of tangency. Okay. So angle ABC intercepts arc BC in this example, and angle DBC intercepts arc BEC in this example or this diagram. Each angle formed has a measure of half. Each angle formed has a measure half that of the arc it intercepts. So the measure of angle ABC in this diagram equals 1/2 the measure of arc BC. And the measure of angle DBC equals 1/2 the measure of arc BEC. That is summarized in this theorem right here. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. That's what we just talked about. Okay. So example 2, find the measure of angle ABC. So we have a secant. AB is a secant because it intersects the circle twice. BC is a tangent because it intersects the circle twice. Find the measure of angle ABC. Well, let's first find the measure of arc ADB. Okay? The measure of arc ADB equals 360 minus 102. That equals 258. So let me label that. 258 degrees is this arc. Okay. A little messy, but that arc is 258. Okay. The measure of angle ABC is 1/2 of that arc. Okay. The measure of, that's the theorem right above. The measure of angle ABC equals 1/2 of 258. So that's going to be 129 degrees. Okay. So that is, again, that was based on the theorem right above. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So the measure of angle ABC was 1/2 of 258, which is 129. Okay. Moving on. Secants and tangents can also meet outside a circle. The measure of the angle formed also involves half of the measures of the arcs they intersect. Okay. So here we go. This theorem, it's a little wordy. Let's go through it. If two secants, which is the first diagram, a secant and a tangent, which is the middle diagram, or two tangents, which is the third diagram, intersect in the exterior of a circle, meaning outside the circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Okay, so the measure of angle A in this diagram equals 1/2 arc DE minus arc BC. Let me get some color to help you see that better. Okay. In this one, the measure of arc DA equals 1/2 the measure of arc DC minus the measure of arc BC. So again, it's always going to be the bigger arc minus the smaller arc. Okay, keep that in mind. And in this last diagram, the measure of angle A would equal, this one's not as easy to color in, but I'll do this one. BDC is this one in blue. Minus arc BC. So since that's so close, let me do that in a different color to help you see the difference. Right there. Example 3. Start off with a nice easy one. They're going to get harder as we go, but let's start off with an easy one. Find x. Okay. Well, let me first start by writing this. The measure of angle C equals 1/2 the measure of arc AE minus the measure of arc BD. You don't have to write that out in a test or quiz. I'm just writing them that so you can see what I'm doing. So the measure of angle C is represented with an x. So x equals 1/2 the measure of arc AE, which is 120, minus the measure of arc BD, which is 50. Order of operations, x equals 1/2 of 70. 120 minus 50 is 70. So x equals 35. This next one is not as obvious. Okay, find x. So here's my question. If this arc is x, how can I represent the other arc in terms of x? In other words, if this, suppose this was 10, what would the other arc be? The other arc would be 350. You get that by doing 360 minus 10. So same idea here. This arc will be represented by 360 minus x. Okay. So find x. 50 equals 1/2 of 360 minus x minus x. Because remember, you subtract the two arcs. So I'm doing 360 minus x minus that x. Okay? Let's make that minus 2x. Again, there's two options of how you can solve this. You can either distribute the 1/2, which is fine, or you can multiply both sides by 2 to get rid of the fraction. So I'll just multiply each side by 2 to give me 100. 2 times 1/2 becomes 1. So 100 equals 360 minus 2x. Subtract 360 on each side. You get negative 260 equals negative 2x. Divide each side by negative 2, and you get x equals 130. Let's do a quick double check on that one, because that one was pretty tough. Let's do a quick double check. I'll do that on a separate piece of paper, on a little scrap paper right here. Okay. I'm going to redraw the diagram. This is our original diagram, as you can see right there. And we got x equals 130. So if I replace this with 130, that means this is 230. Does it make sense? Does 50 equal 1/2 of 230 minus 130? Yes, because 50 equals 1/2 of 100. So 50 equals 50. If you want to double check it, that's how you could do it. I actually would double check number 4 if I were you, because that one was pretty tricky. Maybe number 3 you don't have to double check because that was easy. But number 4 I would definitely double check. Okay. All right, 2 more examples based on that theorem. Okay, number 5, find x. Okay. So my first question is, what is the measure of arc WRV? That is 180 degrees because it's a semicircle, because that's the diameter. So here's what I'm going to do. 45 is the angle. 45 equals 1/2 of 180 minus 10x. That 10x is for the arc. I know it might be hard to see. That 10x is for arc of ZV. Okay. Now again, if this was me, I would just multiply each side by 2 to eliminate the fraction. So it'll give me 90. 2 times 1/2 becomes 1, so you can ignore that now. 90 equals 180 minus 10x. Subtract 180 on each side. Negative 90 equals negative 10x. Divided by negative 10, 9 equals x. Or x equals 9. That one should actually be pretty easy to double check, because you're doing, if you want to double check that, 45, does that equal 1/2 of 180 minus x was 9, so that's 90. And yes, that works, because 45 does equal 1/2 of 90, because that's just 45. Last example, saving the hardest for last, of course, like usual. Find x. Okay. So first things first, I'm going to do (40 equals 1/2 of x squared plus 12x minus x squared plus 2x. But if I were you, I would put that in parentheses. Let's use brackets here. Maybe we do that so it looks a little nicer. Okay, so here we go. So again, 40 equals 1/2 of x squared plus 12x minus x squared plus 2x. But you should put the x squared plus 2x in parentheses, because you have to subtract the whole thing. Meaning it's 40 equals 1/2 times x squared plus 12x minus x squared minus 2x. A lot of times when people subtract, they forget to distribute the negative sign, but you're subtracting the entire thing, so this negative sign has to get distributed to both places. Okay, so minus x squared minus 2x. Okay, Not minus x squared plus 2x, minus x squared minus 2x. Now we're going to combine like terms in the parentheses. 40 equals 1/2 x squared minus x squared, that goes away, so it's actually not that bad now because there's no more x squared term. We just have 1/2 times 10x. So again, you can solve this however you want. You can distribute the 1/2 if you want, or you can multiply each side by 2 to get rid of the fraction. I'll just do that. 80 equals 10x. So divided by 10, x equals 8 for the final answer. Now, I would just double check this one if I were you. So if you replace the x with 8, 8 squared plus 2 times 8, that gives you 80. 8 squared plus 12 times 8. Second. That equals 160. I don't know why it took me so long. I typed it in wrong on my calculator. Okay, so that should be 160. Now keep in mind that these do not have to add to 360 because we're not talking about all the arcs. We're just talking about 2 of the arcs, this one and this one. So they don't have to add to 360. So be careful for that. And so the question is 40 equal to 1/2 160 minus 80? Is that true? So 40 equals 1/2 of 80. 40 equals 40. Yes, it is true. So I know I did it right by doing that. Okay. And that is the end of that lesson. Secants, tangents, and angle measures.